Hey everyone, welcome to this video. In this video, we'll be continuing our course of CS004 where we'll be talking about core Python programming. So in this video, the title for this video is Introduction to Numbers in Python. So the reason why I'm taking this video because I saw that many people are lacking in numbers. Means they don't know what are the most famous built-in functions are and how the numbers are stored internally, and something more about variables to help you understand. Variables are not containers, they are the pointers in Python. Okay, so we will take a look in detail. So this will be the short video, about 20 to 30 minutes on numbers. Okay, so all the source code of this course or the video source code will be available in the GitHub of mine, which the link in the description box below. You can access from there. Okay, so in the previous video I had given you an introduction to Python, and I hope that you all had set it up everything with Python and Visual Studio Code or some other editor. I hope that you are done with that. Now we will start with introduction to Python numbers. Okay, so in the previous video if I go to and see what we have seen in the previous video, so let me open my folder of lecture programs and wait, just wait for a second. It's lecture number 1. So we've talked about the print function, then I've given you some of the introduction to Python, what's the features, and then I've given you comments, the assignments, identifiers, module structure, and memory management in Python. Okay, so in this video we'll be talking about numbers, which is available in Python. Okay, great. So let's start with what are numbers. Is this the great thing? So numbers are actually which you see in real world. It can be integers, it can be decimals, it can be complex, it can be any kind of number, imaginary number, anything. Okay, so what I'm telling is in Python there are certain numbers with the types of numbers which are integers, floating point number, and floating point number are a decimal number. So in programming terms we are given a different name. We have complex numbers and etc. Okay, so how we store the numbers. So here we have, oh my god, yeah, so here we have an int where we are storing 1. Okay, so let me make my favorite test.py where I'll be coding with you so that I can take more examples. I don't want to destroy that, so maybe it may be looking so much of now it should look fine. Great. So you want to store, for example, you want to store an integer. So you want to store an integer. So you will store 4. So you stored 4. Now, if you wanted to print that an integer, that will actually print that. So let me remove this. I'm going to use my favorite command line for this, but most of the case when we'll start off, so we'll be using this Visual Studio interactive window, because that will help us in debugging as well. Okay, so we'll be using Visual Studio Code interactive window to do so. Python programs, lecture programs, and there let me open my command line, and then over here you must have seen the test.py, lecture1 script.py, lecture2 script.py. Okay, so here from here we will run our program. So let's take this here and let's start off. Okay, so you have this an integer. We are stored in a variable an integer, and then you're going to print an integer. Okay, so let me run python test.py. that will actually return full. Okay, so for example, how do you confirm that it is an integer? So for that we'll be using the type built-in, the type that will actually tell you what's the type of that particular whatever they stored. Okay, so let me save that, so it should make sense, and I just gone to python test.py. So it is an integer. Okay, so we'll study about class later on. So this is a integer, right? Great. So here we can also store the decimal numbers which are in terms of programming. We call it as a floating point number. So you can store the float, but actually 4.5, and then if you want to print your favorite type of float, that will actually, if I save this and if I run this, it will say okay, it's a float. Okay, so this is a thing, and you can actually store complex numbers, which we'll see in just a second. So we have stored, you can actually store a long integers, and you don't have to actually remember. Maybe some people try to remember what is the range between you can store the integers, but that is totally waste of time if someone is doing. It's because I have a good reason for that, is why you're remembering the things. So it's to leave programming. If you're remembering the things, it's better to because you already have a Google. For some instance, you can go on Google if you're getting stuck and see what's the range. Okay, so this is the thing that I'm going to give it to you. No company will ask you what are the range of that. If someone's company is asking you, then of course that company is totally bad. Okay, so you can actually store a complex numbers. So you can, over here you can actually store the complex numbers like a complex 4.5j, and when you print the type of that, it will actually be a complex number. Okay, so this is the basic things that you need to worry about, the numbers in Python, and I really hope that you understood these three types of numbers. And there are more like long, which in Python 2, if it is long, then you apply L, but in Python 3 they have deprecated. Now they have their own, you can actually write integer like this, and then you're good to go. Okay, but long you can store like this. So how you're going to update the numbers, but before that I want to tell that one of the function that is very useful, which is input, which you will use input. Okay, input build function. So what it does, so in Python, for example, let's take an example. You wanted to build, you gone into some market, you gone in some market, and there you buy, and you wanted to buy some fruits. The first food that you will buy is of apple. The second food that you will buy is of mango. Okay, so the second food which you will buy, which is of mango, and third food which you will buy, which is orange. Okay, so you want to calculate or check whether your budget allows to buy three fruits, allows these fruits. So what you want? You want the price of an apple, the price of a mango, and price of an orange. And you also want your budget, what's your budget is. So you will, what you will do, you will add these three, and then you will check whether this is greater than. If it is, then we will not buy these three food. If it is not, then we'll buy these three foods. Okay, so this is the basic thing. Okay, so let's code it. Let's code this bit of program to help you understand what is actually happening. So you write apple cost is 45. Actually, if you're seeing the code completions, is because I have activated my codex. It's Copilot, so don't worry about that. And it may happen that you are not able to see. So 60 rupees per kg, 45 rupees per kg, and orange, if I go on orange, that is 75 rupees per kg. Okay, so these are the three. Now what I will do, you have a budget of 200 rupees per 200. Okay, you have a budget, you have a rupees of 200. Okay, so you want to check whether you can buy these three fruits in this budget. Okay, so how you will proceed further? So proceeding further, you will write sum of fruits, that is actually apple, that is actually apple, mango and orange, and then you will check that will actually contain the boolean, so you will check whether that budget or whether that sum of fruits is smaller than or equals to budget. Okay, and then you will print out. Okay, so if it is true, if the sum of all the fruits is smaller than the budget or equals to budget, then it will say okay, you can buy. If the sum of fruits is greater than a budget, then it will say you cannot buy. Okay, so let me print out the check. Okay, so this is the basic program for writing this problem statement. So let's see how it is working and everything. I don't want to run it over here, but let's remove it. Let me go over there and let me run it out. So this will say true. So you can see over here that if I run again, it is saying true. So if you format, if you can format like this, you can buy the fruit or not. Okay, so you can actually write it over like this. Now which should make sense to you. So when you run it, you can buy a fruit or not, and then it's true. We can actually use if in a statement to work on this like this. If the check is equals to true, then return, then print, you can buy the fruit, otherwise else you cannot. Okay, you can't buy the fruit. Okay, so this looks more formatted. So it is checking if the check is equals to true. If the check is equals to true, means you can buy, then you can buy. Otherwise, if the check is false, then you cannot buy that fruit. So that will actually make sense to you. You can actually buy the fruit. Okay, so this is how it is working. We will take a brief summary on if and else statement later on, but just for your information, I have written it out. Okay, so for example, you want apple, mango, orange will be changed. Will be keep changing. You want is to ask from the user, na? So what you will do, you will ask the user to enter from the terminal. Okay, so you want input, you will ask enter the price of apple per kg. Okay, so it will be entered by the user, and make sure that this price should be an integer, not that. Okay, you can actually ask for float, you can actually ask for integer, anything will work. Okay, you want the same in the mango per kg, and you are going to ask for this as well. Okay, price of a orange per kg. So now when you run it, it will ask you first enter the price of an apple per kg, 58, and the price of a mango per kg, let's write 120, and then orange, then let's write 120. You cannot buy the fruit because when you sum it out for 58, 120 and 120, that will actually be, you cannot buy the fruit because it contradicts this statement. Okay, the actual return is false. Great, so you have written it out. First is ask for apple, then you can actually write from terminal because it is provided by the user. Now what if you want this also? So you want this to be also given by the enter your budget from the user. Now you have a totally functional code, and when you run it, now it will ask for, let's say for sake of example, your price is then 45, then 65, and your budget is actually 2 rupees. So you cannot buy the fruit. Okay, so if these are the fruits. So this is the basic system for calculating whether you can buy the fruit or whether you cannot buy the fruit. Okay, so this is the basic thing. You can actually we will study about functions so that we can reuse the blocks of code, but as of now it's not needed. So what we have done so far is taken out the apple, taken a mango through the input from the user and budget, and then we have done the sum of these three, and then we have checked whether it is smaller, is greater, is smaller than or equals to, whether the sum of fruits is smaller than or equals to the budget. Okay, if the check is true, you can buy the fruit. If the not, then you cannot buy the fruit. Okay, so this is our basic the thing that we have written, a program that we have written to help you understand more, and I really hope that you understood very clearly. Okay, so I hope that we will keep making these type of programs, better programs, to help you understand what is happening, what is not. So I hope that you understood. Now, so I will just, I will not do anything with it. I will just go on the next part. Okay, so I will just go on the next part. So I'll just, by making these lines. So the next thing that I want to talk to you, that how to update the numbers. This is the biggest topic in this video. Okay, so you might be thinking, hey Ayush, what I can do is, for example, you have x and y where it contains 45. You want to change this x and y to be 50. You changed it. Okay, now you changed it, but let me know, I want to ask you, let me know whether you are really changing the value of this to this 45 to 50, really, in Python, whether you're really changing. If you've remembered, I had said in previous video, Python is not passed by value, it's passed by reference. So in this video I will elaborate it for 5 to 10 minutes for more. Okay, so please take a time to understand, it will be really changing, it will be not. You may think, hey Ayush, you are just updating. You just said in a previous video that x and y, the variables acts like a containers. Variables act like containers to store the value, and you can actually update the value without adding the number. You can actually you are updating the value, but you are not really changing the value 45. Okay, so in Python, the variables acts like a numbers are actually immutable. Okay, so it simply means that it works as a pass by reference rather than pass by value. So I will explain you what is this. So in Python, the variables acts like, I'm just changing my point of view from the previous video, because previous video was the introduction. Now getting into that. So x and y or variables are x and y or variables are acts like pointers. Okay, so pointers. So what do you say? So you're first of all, this variable is pointing to 45, now when you update it, now this is not really changing this 45 to 50. Now this variable is pointing to another value. Okay, it is not being changed. Okay, it is not being changed. It is just that this variable is pointing to another box, which is 50. So this is the basic thing. So here we are not actually acts like a value or pass by value. We pass the reference. Okay, this is the referencing this value, not actually holding this value. Okay, so in various tutorials they don't tell you about this fact, about what actually happens internally, but I told you it's better to keep in your toolbox. Great. So we had talked about how we can update the numbers. Now it's time for deletion of variables. So it may happen that in usual world you are not going to delete the variables, but if you want to delete, there is a del keyword, which is a reserve keyword, and you can actually write x and y. That will oh my god, yeah, so that will simply update your delete your variables. Okay, so this is the basic thing, and you can actually use when you have some criteria, like you want to build you're making some function, and actually you don't use this, you simply remove this kind of thing, or simply do not use that. So this is what the thing is. You can actually remove with a del keyword. Great. So now we came to the last topic of this lecture. Is there are some types of numeric integers that we will continue to talk on. So some of the integer types are, we have integers, we have floating point numbers, we have complex numbers. Okay, so we will study in detail. So what are integers? Integers are zeros or positive or negative whole numbers without any fractional part. I hope that everyone has studied integers. So some of the examples of integers are, which is 4, 5, minus 6 is the mixture of both positive and negative, including 0, without any fractional part. Okay, so whatever we were storing is, these are the integers. Okay, in Python we have int reserved keywords for that. Great. So integers can be binary, it can be octal, it can be hexadecimal values. So let's see this. What are octal and what are hexadecimal? If you have studied binary to decimal to binary conversion in your class 6th or 7th about this, so you should know about this octal, octadecimal, then hexadecimal, and etc. Okay, so you can actually store octal with going from 0 O and then 1 2 and zeros x 1 2. Okay, so when you can actually store your octal into 0 O 1 2. Okay, you can actually store your favorite 0x12. Okay, so you can, if you want to convert it into numbers or decimal format, you can actually do just by print and then print out that, and that will actually do for you. Okay, so we will see that. So this floating point number, of course everyone knows about floating point numbers. Floats are this, which are in decimal format. Then we have strings. I don't think that strings are, we will be having another section on strings, but now not. Will be complex numbers. Complex numbers are made up of real and imaginary parts, which you all have started. If not, don't worry about it. So what is the syntax? It's real plus imaginary j, and both real and imaginary components are floating point values, and imaginary part is suffixed with a letter z, lowercase z or uppercase z. Okay, so let's view some of the properties of a complex numbers. So let's view that. So let me take this over here, and then let me do we have a complex. If you want to take out the real part, you can actually take out the real, and then when you do so, I don't know why it's doing so. Okay, so let me remove it. I have a practice to do from there rather than here, so I'm just commenting it out so everything works great. So minus 8.35 is the real part of that. This is okay. So if you want the imaginary part of complex dot imaginary, when you print it, that is actually minus 1.47. Okay, you can actually print out a conjugate of this, and that will actually work for you in many cases. That is minus 8.3 and then go on. Okay, so these are the conjugates. So these are the complex numbers that we have studied so far. Now we will see some of the standard types of operators, which is and or operator. Okay, and this equals to operator as well. So let's see these equals to operators. So you may know about, you are assigning over here. So if you have seen over here, if I uncomment it out, you have seen over here that we have this two equals to sign, and here we have a equal sign over here. So these are assigning this value into this variable, although it is a referencing, but here we are checking with these through whether this is check is equals to true or not. Okay, so this checks whether it's equal, whether this variable value is same as this value. If it is, then we go this. So this is called the assign. This is called the operator, which is double equals to. Okay, another we have, for example, you wanted to check whether 5.2 is greater than 6 and 6 is greater than 4. Of course, this will be no, it is not, because here the contradiction occurs. So in the same way, we have written over here that sum of root is smaller than or equals to budget. If the sum of roots is smaller than or equals to budget, it will either return true, because this will be a boolean value, because it will only say true or false. Okay, so this is the boolean, and boolean is a true and false. For example, when you print this out, the last one, let me uncomment it again. When you print this out, the last one, it actually be, oh my gosh, why it hasn't? So you want to print first. Okay, so let's print it out and actually say no, this is the false, because here the contradiction occurs that 5.2 is smaller than 6. Okay, so here the contradiction occurs. Now what if the same way we have written over there? Now what if you want this to be written in some AND or OR format? So what is that? So here I'm making one bar that will actually store true and false. Okay, so first we check 5.2 is greater than 6, and 6 is greater than 4. You can actually write the same statement in this format. Why we should write in this format? Because this is more organized. It is more organized. So you will get to know why we are using this and what and does. Okay, so it actually tells false. So if I put or, so what will happen? Anyone can guess? So true. Why it's true? So let me explain you the difference between and or. So and means, in terms of programming, is both the conditions should satisfy. Both the condition. If you are writing 3, then all the conditions should satisfy. All the conditions should satisfy. Even the one condition fails or contradicts other, then all will be regarded as a false. Okay, so even if one condition fails, all will be regarded as a okay, as is false. If we put or, even at least the one condition runs, even at least the one condition runs, then it will be regarded as a true. Okay, so that's the basic thing, that's the basic theory behind the and or operator. In the next video we'll see more about the bitwise, where we're talking about and or with some more advanced examples. Okay, so let's talk about some of the operators like classic division, floor division, and exponentiation. Okay, so you can actually do the classic division that you usually do, 1 by 2, that will actually return 0.5. For example, you wanted to round it. So for example, you want to nearest. Okay, so you first of all let's print it out. Let's print a, and let's see what is the answer of that. It's 0.5. Now you want this, the division should be rounded off, to round in the certain range. Okay, round. Okay, just round it. You write a equals to 1 /2. What it will do, it will actually round that a to the nearest, whatever the nearest is. Okay, so when you run this, it will actually, the nearest is 0. Okay, so this is how it is rounding off these two. This is called the floor operations. This is called the floor operations that you do. Okay, so this is the basic thing. Now if you've studied about exponents, you can actually take the exponents of 2 to the power 2, or it's just simple to 2 to the power 2 like this. You can actually do for any numbers, maybe 1000. Let's do for 1000, and let's check for the same. Let's do for 1000. Let's check for the same. That are actually this much number. Okay, so this is the basic thing, 10,000. So this is the exponent's powers. Okay, so I hope that everyone has understood. Everyone understood on this. Now let's talk about examples of numeric operators. Okay, so I am not going to do this here. What you are doing, you are actually doing different stuffs, assignments, then you are adding the numbers. So this will be your assignments to test it out how it is running, and I've added some octadecimal, hexadecimal, complex numbers and everything. So you have to see this. The next thing which you have to see, which I will talk about in the later videos, is precedence rule. Precedence rule. Either I will ask Codex to print the precedence rule. So I just hope that precedence rules. Codex, I want to print it out. Yeah, so I will you have to see it. Okay, so please be sure to see the precedent rules over the internet, because I'm not here to spoon feed you. Because it's in a real world, in real maths, we use BODMAS to evaluate one expression or evaluate one kind of thing, simplify it. Okay, so but in programming terms, we use precedence rule to solve a particular expression. Okay, so you can actually review this and let me know in the next video. We will talk about these things. Okay, so there are some built-in functions like absolute value. Absolute value is just makes it to the positive side, and then div mod. For example, you want to take out the quotient and then the remainder. So what you will do? So you want to take out the quotient and then the remainder. So for example, let me comment it out everything. Now for example, you want first of all quotient and then the remainder of 10,3. Okay, so let me print it out as well rather than. So I'm just going to print it out everything, and then I'm going to run it. Okay, so first it gives out the quotient and then the remainder. So this is the one of the built-in function. Then we have hex. Then we have hex of 5. That is actually let me show you. Print hex of return the hexadecimal representation of an integer. Okay, so when you save it, it returns the hexadecimal. You can do the same for octadecimal. To if you're in some of your examination, it will actually help you. So you may think that in Python we were storing our some integers. Okay, so for example, we are going to store our a. Okay, we are going to store our a. So how this a is stored in internal memory? First this a is converted into some numbers that is called ASCII values. Okay, so this if you print what is the odd, means what is the number of this, what is the ASCII value, of this? It's 65. Okay, so this is how the numbers are stored. First it is converted in ASCII value and then it's go further. Okay, so this is the basic thing. You can actually if you write some 97 and ask them to print char, I don't know, yeah, so you can actually ask them to print and then you will get that alphabets as well. Okay, so this is the basic introduction for you to help you understand what is numbers. Okay, so I hope that you understood how the variables are stored, and we also have taken some of the cool examples like this to help you understand more of the topic. We have also studied about these string. Let me uncomment it out everything so it looks cool to you. So I will just comment the things which are not needed. So you can actually you can actually learn a lot from this video, and we have actually gone so much of comprehensive in this course. So let's discuss some of the assignments that I've given to you in our previous video. Is take a look at the escape sequences. I hope that you have taken a look. Take a look at a print function and do a bit of a study, which will a video will be coming soon. There is the next video will be the whole story of bitwise operators. Then we will wrap up the numbers. Okay, and then we'll move further into this one, which is called if name is equals to main. Okay, so I hope that you like this video, and then let's wrap up this video. Meet you in the next video.